Blue skies, nothing but blue
Are you gonna
skies.
sing?
I could.
Mr. Blue
Someone was
Yeah,
talking
I
about
mean-
your singing the other day. Now I got to think about that.
Okay, now,
That'll take
oh,
me a
not
while.
another thought. No, that'll take a whole segment. Well, Jacob, I guess it's about blue
I
skies
need to
and
listen to Jacob. though.
good
Yeah,
one,
think
yeah.
I hope we can have some recollections of meteorology class with
Yes.
these lessons that I'm going to
No
go
doubt.
over here with our dry air in the winter. With the cold air that we usually have in the wintertime, that can hold a lot less water vapor than warm air can in the summertime. So cold air, less water vapor leads to drier atmospheres in the wintertime versus we have that more humid air mass usually in the summertime. And that leads to a bunch of interesting impacts. But let's focus on this statement here. Cold air can't hold as much water vapor as warm air can. As the temperature of the air decreases, the water vapor molecules slow down. There's less energy in the air. Less energy with those molecules. They're more tightly packed together versus with warm air. These molecules are moving around a lot faster. There's more space in between them. Cold air, again, the energy decreases. You get all of them to be more compact with each other, and they're moving a lot slower. And the little bit more of a technical side to it, the evaporation rates are decreasing when the temperature of the air is lower as well, making it possible for the condensation rate to actually exceed the evaporation rate. And the take-home message here, again, more energy with your warmer air. There's more of those molecules moving around faster. The higher evaporation rates gives the potential for a higher number of those water molecules to remain in the vapor state without net condensation occurring, meaning it can hold more water vapor. There can be more energy in here without that condensation happening. Again, the evaporation and condensation rates are just a lot higher with warm air, and therefore there's more water vapor, more moisture in the air when there's a warmer atmosphere. So the dew point is the absolute measure of the amount of water vapor in the atmosphere. Again, that's the best measurement that we have, better than relative humidity, which can fluctuate throughout the day. And dew point is always less than air temperature. And here's the scale here, where dry air is going to be less than 45 degrees for your dew point, whereas you get the summertime dew points where it gets a lot more muggy and oppressive. But in the winter, that dew point, again, the absolute measure of the amount of water vapor in the air is usually less than 45 degrees, and it can be a lot lower. Right now, dew points are in the 30s across the area. Again, very dry air in place during the winter time. Here's the dew point throughout 2023, going from January on the left side of this graph all the way through November and December. And you can see during the summertime here, dew points were in the 40s, 50s, 60s, even some 70-degree dew points, versus in the winter, again, that absolute measure of the amount of moisture, the dew point was in the teens, 20s, even in the sub-zero category for a lot of days. In 2024 so far, when we had that big cold snap in January, our dew points plunged down into the minus 20s and even minus 30s because the dew point has to be lower than the air temperature. So you have a dew point of, let's say, 5 degrees. The air temperature would have to be above that, let's say, 20 degrees. So health impacts of having that air being drier in the wintertime, you have dry skin, dry sinuses, which can lead to more sickness because you have more dried out mucous membranes in your upper respiratory system. That makes them far less effective at catching bacteria and viruses before they make it into your lungs. You have more chapped lips, nosebleeds, and eye irritation with that dry air in the wintertime. Another thing I wanted to focus on is static electricity is usually a lot more prevalent in the wintertime with this dry air. So looking at atoms, and the composition of atoms are electrons, which are floating around outside the nucleus, and then in the nucleus you have the protons and the neutrons. But the electrons are easier to lose from those atoms. They're on the outer rings. And we lose those electrons throughout the day just by rubbing against clothing, blankets, or carpet. So we become positively charged because we're losing those negative charges. And with that buildup of positive charge within our bodies, when we touch neutrally charged objects, especially metal ones, that discharge happens, and it can be pretty hair-raising or super shocking. And on a more humid day in the summertime, the water vapor, the invisible water vapor molecules in the air around us, is actually a good conductor, and that can conduct that excess positive charge away from us. Versus on a dry day, in the wintertime especially, less water vapor in the air around us, so our body holds on to those higher positive charges, and that discharge will therefore be greater. So a solution would be to add a humidifier to your home if you have a lot of static shocks that happen. Because the air is actually drier inside your home than outside, because the furnace in your house pulls in that dry air and heats it up. And as it heats it up, let's say it's 35 degrees outside with a dew point of 10 degrees, and the temperature inside your house, again, we're heating that air up, but keeping the moisture, the dew point the same, that relative humidity percentage is going to be a lot lower. So the air is going to be even drier inside your house as that air is heated up with the furnace. So interesting impact there of the dry air. Again, increased static electricity. Looking outside, though, the sky is usually a deeper shade of blue in the wintertime versus the summer because of that dry air. In the summer, with more water vapor molecules in the atmosphere, those scatter the blue light out, and you can kind of see that hazier or milkier white appearance to the sky a lot of times. Versus in the winter, with less moisture, smaller water droplets in the atmosphere, and a lower sun angle, that all contributes to this really rich blue appearance to the sky a lot of times. You can see this side-by-side comparison just from an example here. It's a process called Rayleigh scattering that we get the blue light. With water vapor molecules that are a little bit larger, that's a process called Mie scattering. I'm not going to go into the technical details here, but when you have more water vapor molecules, that allows for more of that blue light to be scattered out, and you can get more of that white appearance. Also, the sun angle plays a role here, as I mentioned. In the wintertime, the sun is going through more of our atmosphere. It's at that lower angle, versus in the summertime, it's going through less of our atmosphere, and there's less of that Rayleigh scattering going on, and we can get the more rich blue color in the wintertime with the lower sun angle and the drier air in place. So interesting impacts of the dry air in the wintertime.
Right, Jody? I know you know this hair, you know.
See, I don't have the hair
You don't
raising
have
I was
that
gonna
effect.
say, you don't have that problem, that's for sure. But
I noticed something in those graphics, Kevin. I don't know if you saw that. Did
What's
you
that?
see you made an appearance?
There's
I
a few
did.
Easter eggs I put in some of those graphics.
really
Yeah.
nice. I'm gonna
I
go
was
back and
paying
look.
more
I was
attention
looking at all the
than Kevin.
science behind what he was doing.
Good
so,
stuff.
yeah.
Thank you, Jake.
Thanks a lot, Jacob.